A rare visitor from deep space is passing through our solar system. This object, now officially named Threeey Atlas, has astronomers excited. It's a mysterious interstellar traveler moving at an incredible speed of over 150,000 mph and could be as large as 12 meters across, considerably larger than its predecessor, Oumuamua. Telescopes around the world are working quickly to study its unusual glow, trajectory, and the faint haze surrounding it. Some speculate whether it's merely a frozen rock or something far more extraordinary. This massive visitor from another star could hold secrets that might change our understanding of the cosmos. Late June 2025 witnessed an extraordinary event in the night sky. Astronomers detected a mysterious object racing through our solar system at a staggering pace. This was no ordinary space rock or comet. It originated from beyond our solar system, making it only the third confirmed interstellar object ever observed. The object, formally named Threeey Atlas, has sparked widespread excitement across the astronomical community. At first, when it showed up in telescope data, astronomers were unsure what to make of it. Was it just an asteroid, a comet, or something completely new? But as more observations came in, it became clear that this visitor did not belong to our solar system. What makes this discovery remarkable is how rare interstellar objects truly are. For centuries, humanity has cataloged thousands of asteroids and comets orbiting the Sun. But objects from other star systems remain an exceptional find. Before 2017, none had been confirmed. Now, with Threeey Atlas, the third such visitor has been discovered within a decade. This isn't just a random space fragment passing through, it's a messenger from a distant star system, carrying clues about worlds we may never physically reach. The story of its discovery, nature, and future path reads like a cosmic detective tale, keeping astronomers glued to their telescopes as it speeds through our solar neighborhood at an astonishing 152,000 mph. The journey of Threeey Atlas began on an otherwise ordinary night between June 25th and June 29th, 2025. The Atlas system, Asteroid Terrestrial Impact Last Alert System, was carrying out its routine task of scanning the night sky for objects that might pose a threat to Earth. Telescopes in Hawaii and South Africa, part of this automated Guardian network, constantly watch the skies day and night, seeking the unexpected. And that's exactly what they found. Initially, the object appeared only as a faint dot moving against the starry background. The system classified it as interesting but not extraordinary, just another object to catalog among the many near-Earth entities. The object was first designated 11PL3Z, a nondescript identifier among countless others. Things took a turn on Tuesday, July 1st, when astronomers observing with a Chilean telescope noticed its unusual behavior. Its trajectory didn't match that of typical solar system objects. It was moving too fast and followed an unpredictable orbit. Follow-up observations on July 1st and 2nd confirmed the suspicions that this object was not orbiting the Sun but merely passing through. A breakthrough came unexpectedly from an amateur astronomer, Sam Dean, who reviewed earlier Atlas images from late June. He spotted the same object in those images, providing invaluable data on its path across the sky. By Wednesday night, the Minor Planet Center, the official tracking body for solar system objects, had received over 100 confirmed observations from telescopes globally. Some astronomers even noticed signs suggesting the object might be a comet due to a faint haze of gas and dust around it. With this accumulating information, scientists felt confident naming it Threeey Atlas. The 3I marks it as the third confirmed interstellar object, while Atlas honors the telescope system that first detected it. Paul Chaz, director of the Center for Near-Earth Object Studies at NASA's Jet Propulsion Laboratory, highlighted the tremendous speed of the object and confirmed its origin from interstellar space. Tracing its orbit backwards suggests it approached from the vicinity of the galactic center, proving it originated from another star system, though which one remains unknown. The confirmation of a third interstellar visitor in under 10 years has led scientists to rethink how common such objects might be. Improved technology may finally be allowing astronomers to detect these cosmic wanderers that have likely been passing silently through our solar neighborhood for ages. What sets Threeey Atlas apart from the multitude of other objects zooming around our solar system? First and foremost, its dizzying speed of roughly 152,000 mph. This extraordinary velocity, combined with its size and mysterious appearance, makes it stand out as an exceptional visitor from beyond the stars. This moment offers a rare chance to study matter from another star system, a precious scientific gift arriving across the vast emptiness between stars. Its passage is a cosmic message, inviting us to unlock secrets of distant worlds and the universe beyond our own solar system. Traveling at such an incredible speed, Threeey Atlas could reach the moon from Earth in just about an hour and a half. This velocity far exceeds that of most objects in our solar system, which move slower because they are gravitationally tied to the sun. In contrast, Threeey Atlas is merely passing through, scarcely influenced by our star's gravity. Its sheer speed indicates clearly to scientists that this visitor is not native to our solar system. Tracing its path backward reveals it doesn't orbit the sun like the comets and asteroids familiar to us. Instead, its trajectory points outward toward deep space, likely coming from the direction near the galactic center, though the precise star system it originated from remains a mystery. Its brightness is another puzzle. When Harvard astronomer Avi Loeb examined the data, he found something surprising. Threeey Atlas reflects a significant amount of light for an object from interstellar space. This could mean it either has an exceptionally reflective surface or is enormous in size. If its surface is as dark as typical asteroids, Threeey would need to be about 12 miles, 20 kilometers, wide to produce such brightness, making it huge compared to previous interstellar visitors. For comparison, Oumuamua was estimated to be roughly 100 meters in length, while Comet Borisov measured about 400 meters across. If current estimates hold, this new object is dozens of times larger than either of those. Another interesting feature is the comet-like behavior observed. Several telescopes detected a faint coma, a hazy envelope of gas and dust around the object, which suggests it could be a comet, although one quite different from those within our solar system. As it approaches the sun and warms up, it may develop a visible tail, which will help scientists learn more about its composition. Its orbit is unusual too. Most solar system objects move close to the same flat plane, a giant disk with the sun at its center. But Threeey plunges through this disk at a steep angle, further confirming it didn't form alongside our planets. The more astronomers study Threeey Atlas, the more they realize its uniqueness. This is no ordinary space rock. It's essentially a time capsule from a distant star system, carrying secrets about worlds we cannot easily visit. Each night as telescopes focus on it, new insights about the universe beyond our solar system emerge. To understand why Threeey Atlas has caused such excitement, it helps to look back at the brief history of interstellar object discoveries. Prior to 2017, humanity had never confirmed a single visitor from beyond our solar system, not one. For centuries, all observed celestial objects orbiting the sun were known to belong here. That changed on October 19, 2017, when Hawaiian astronomers detected an unusual object using the Pan-STARRS telescope. This object, named Oumuamua, meaning scout or messenger from afar in Hawaiian, was unlike anything previously seen. It had a strange shape, either cigar-like or pancake-flat depending on interpretation, and tumbled through space, reflecting sunlight in ways that caused its brightness to fluctuate dramatically. What baffled scientists most was Oumuamua's acceleration as it left the solar system. It sped up slightly, an unexpected behavior since objects normally slow down as they escape the sun's gravitational pull. This mysterious acceleration sparked intense debate. Some argued it could be caused by outgassing, invisible gas jets acting like tiny rocket engines. Others, including Harvard's Avi Loeb, proposed more extraordinary explanations, including the possibility that it might be an alien light sail or spacecraft. Oumuamua left our solar system quickly, before the most powerful telescopes could fully study it. leaving behind more questions than answers. Then came the second interstellar visitor in August 2019, discovered by amateur astronomer Gennady Borisov. Unlike the enigmatic Oumuamua, this object, named Comet 2I/Borisov in his honor, was unmistakably a comet, showing a visible tail and behaving like those in our own solar system. Borisov was easier to study as it was spotted months before its closest approach to the Sun. Scientists estimated its size to be about 400 meters across and composed of materials similar to comets found in the outer reaches of our solar system. This similarity suggested that comet formation might follow common principles across different star systems. These two interstellar visitors provided fascinating but contrasting glimpses into objects from outside our solar system. Oumuamua was strange and unfamiliar, while Borisov seemed familiar. Now, with Threeey Atlas as a third example, there is more data to help scientists determine patterns of what is usual or unusual among these cosmic travelers. The rapid rate of these discoveries, 3 in less than a decade after centuries of none, has led many to wonder if interstellar objects are much more common than previously believed. It's possible that such interstellar objects have been drifting through our solar system all along, and only now have our detection capabilities improved enough to notice them. Following the path of Threeey Atlas reveals a remarkable journey through our cosmic neighborhood. As of early July 2025, it is speeding through space at over 152,000 mph. It is currently located about 3.8 times farther from the Sun than Earth, placing it beyond Mars' orbit but still inside the asteroid belt. Unlike native solar system objects, Threeey Atlas is not orbiting the Sun. Instead, it is traveling on a hyperbolic trajectory, essentially a one-way route that will carry it through our solar system and then back out into interstellar space, never to return. If its path were traced backward in space and time, it would point toward the center of the Milky Way, though identifying the exact star it originated from is nearly impossible. The vastness of space and the millions of years the object may have journeyed make this akin to trying to determine from which cloud a particular raindrop fell. The trail has effectively been lost to time and distance. Looking forward, Threeey Atlas has some notable milestones in its approach. On October 3, 2025, it will pass closest to Mars. This will be the first time it nears one of our planets, allowing astronomers to observe any slight gravitational effects Mars may exert on its path. Then, on October 23, 2025, Threeey will reach perihelion, its closest distance to the Sun. Even at this point, it will still be about twice as far from the Sun as Earth. This distance is significant for several reasons. First, the object won't be subjected to intense solar heating that might cause it to fragment if it is a fragile comet. Second, it confirms that Threeey Atlas poses no threat to Earth. Interestingly, Earth itself will be on the opposite side of the Sun when Threeey Atlas hits perihelion. The closest it will approach our planet will occur in December 2025, and even then, it will remain at a safe distance. After this encounter, Threeey will continue its long journey back to interstellar space, accelerating as it escapes the Sun's gravitational pull. What makes this passage fascinating is that Threeey is essentially a temporary visitor, a cosmic tourist briefly traveling through our solar system on its eternal journey across the galaxy. It likely formed around another star billions of years ago and has been drifting through the emptiness of interstellar space for millions of years before arriving in our stellar neighborhood. Arriving without warning, it will soon depart, continuing onward to unknown destinations, carrying with it a brief record of its interaction with our Sun and planets, a story that may never be deciphered unless it encounters another advanced civilization capable of decoding it. The discovery of Threeey Atlas represents more than just an astronomical curiosity. It is a treasure trove for scientific research with the potential to transform our understanding of how planetary systems form throughout the galaxy. Until now, the only planetary system we could study directly was our own. Our knowledge of planet formation, asteroid composition, and comet behavior has been based solely on objects originating around the Sun. Now, with Threeey Atlas passing through our cosmic vicinity, we have a real fragment from a distant star system in our hands. It's like being able to pick up a rock from Mars and inspect it without sending a rover. This presents a rare chance to study material created under conditions entirely different from those in our early solar system. What makes this opportunity even more exciting is that Threeey Atlas appears to be significantly larger than our previous interstellar visitors. Its size allows for better observations, more detailed spectral analysis, and potentially a more precise determination of its composition than what was possible with Oumuamua or Borisov. If Threeey Atlas is indeed a comet, as early observations suggest, it gives scientists the rare chance to compare its ice, dust, and gas components with those of comets from our own solar system. Are the same chemicals present? Are their ratios similar? The answers to these questions could help determine whether the building blocks for life as we know it are common across the galaxy or unique to our local environment. Another advantage is that this object was detected relatively early in its journey through our solar system. Unlike Oumuamua, which was already leaving when discovered, researchers will have months to study Threeey Atlas as it approaches the Sun, reaches perihelion, and eventually departs. This longer observation window enables astronomers to coordinate studies using a variety of telescopes and instruments worldwide and in space. The timing couldn't be better from a technological perspective. When Oumuamua passed in 2017, the James Webb Space Telescope hadn't yet launched. Now, with Webb operational alongside other advanced observatories, we possess unprecedented tools to examine this interstellar visitor in great detail. Perhaps more importantly, each newly discovered interstellar object helps answer a fundamental query: how common are these visitors? Before Oumuamua, some scientists estimated that such objects might be seen once every several decades. Now, with 3 confirmed in less than 10 years, those estimates are being dramatically revised. It appears likely that interstellar objects traverse our solar system much more frequently than previously thought, possibly several times per year, with most going undetected because they are either too small or too distant. If interstellar objects are indeed common, it suggests that planetary systems throughout the Milky Way regularly eject material into interstellar space. This, in turn, provides insights into how planetary systems evolve and interact across vast distances and timescales. Despite our advanced technology and brilliant scientific minds, Threeey Atlas holds many mysteries that continue to puzzle astronomers. One of the biggest questions is its exact nature. Is it a comet, an asteroid, or something entirely new? Early observations hint at cometary activity, with a faint fuzzy appearance suggesting gas and dust might be escaping its surface as it warms from the sun. However, it lacks the prominent tail typically associated with comets. Some astronomers propose it could be a pristine comet, one that has never passed close to a star before and thus still retains its original ice. Its unusual brightness also poses a mystery. As Harvard astronomer Avi Loeb noted, Threeey Atlas reflects more light than expected. If it has a dark surface, similar to most asteroids, it would need to be enormous, around 12 miles across, to appear this bright. Conversely, if its surface is highly reflective, it could be considerably smaller. Determining its true size and reflectivity remains challenging even with our best telescopes. Another puzzle is its rotation. While most space objects spin as they travel, measuring Threeey Atlas's rotation rate has proven difficult. Some data suggest it may be tumbling chaotically rather than rotating smoothly on one axis. If true, this might indicate the object experienced a violent event in its past, such as a collision or a close encounter with a massive body that disrupted its rotation. Questions about its age and origin remain open as well. Did it form recently around a nearby star? Or has it wandered through the galaxy for billions of years? Surface features and composition may hold clues, but achieving that level of detail requires observations not yet possible. Perhaps the most intriguing mystery is what Threeey Atlas might reveal about its home system. Every star system leaves signature fingerprints on the objects born within it, unique elemental ratios, specific minerals, and isotopic compositions. If we can decode these signatures, we might learn about a planetary system we may never visit. Some astronomers are also watching for any signs of non-gravitational acceleration as Threeey Atlas travels through our system. Oumuamua exhibited such acceleration, which sparked considerable debate. If Threeey Atlas also shows unexplained accelerations, it could suggest this behavior is common among interstellar objects, rather than a unique trait of Oumuamua. These mysteries make Threeey Atlas far more than just another object to list in catalogs. It is a cosmic puzzle box, with each new observation potentially unlocking another secret about its nature and history, with several months remaining to observe it before it departs our solar system forever. Astronomers hope to solve some of these puzzles before saying farewell to this interstellar visitor. When discussing visitors from beyond our solar system, one question often captures the public imagination. Could it be artificial? Could this be an object created by intelligent beings from another star system? This question goes beyond science fiction speculation. Avi Loeb, one of the most respected astrophysicists globally, has openly considered this possibility, especially after the puzzling observations of Oumuamua in 2017. Loeb famously proposed that Oumuamua might have been an alien light sail or probe, based on its unusual acceleration and peculiar shape. With Threeey Atlas now in the spotlight, Loeb has once again suggested that scientists should use the powerful James Webb Space Telescope to search for signs of non-gravitational acceleration, movement that cannot be explained by gravity alone. If such a force is detected, it could potentially indicate some form of artificial propulsion. However, before jumping to conclusions about alien spacecraft, it's important to recognize that non-gravitational acceleration can occur naturally as well. Comets often exhibit this behavior because when heated by the sun, ice on their surfaces turns into gas, creating gentle thrusts that act like tiny rocket engines. This outgassing can subtly alter a comet's trajectory in ways that pure gravitational models don't predict. What would make Threeey Atlas truly suspicious as an artificial object? Various factors could raise questions among scientists. If it changes direction in ways that defy known physics, emits radio signals or other signs of technology, or has a composition featuring elements or isotopes in combinations that cannot form naturally, these would all be major red flags. Additionally, astronomers are observing whether Threeey maintains steady brightness or shows consistent patterns in how it reflects light. Natural objects usually have irregular shapes, causing variations in brightness as they spin. A steady brightness might suggest a more regular, possibly artificial, structure. While exploring artificial origins is scientifically valid, history shows that natural explanations tend to prevail. When pulsars were first discovered in the 1960s, their highly regular radio pulses led some scientists to briefly speculate that they might be alien beacons. Today we understand that they are rapidly rotating neutron stars, exotic but naturally occurring objects. Still, the possibility, however remote, that we might be witnessing technology from another civilization adds to the fascination these interstellar visitors inspire among both scientists and the public. It challenges us to confront the profound question: are we alone in the universe? Even if Threeey Atlas turns out to be a natural comet or asteroid, the thorough investigation of all possibilities, including artificial origins, advances our scientific knowledge. As Carl Sagan famously said, extraordinary claims require extraordinary evidence. Although most astronomers find it highly unlikely that Threeey Atlas is artificial, they will undoubtedly be searching for any remarkable evidence suggesting otherwise as it journeys through our solar system. Studying a dark object, possibly smaller than a city, moving at 152,000 mph and billions of miles away requires serious technological capability. And fortunately, we now possess more advanced tools than ever before. Currently, astronomers worldwide are directing all available telescopes toward Threeey Atlas, creating a global effort to understand this visitor before it exits our neighborhood forever. Ground-based observatories in places like Hawaii, Chile, and South Africa track its movement, measure its brightness, and analyze the faint light it reflects to gather clues about its composition. However, the real game changers are our space-based observatories. The James Webb Space Telescope, with its massive 21.3-foot mirror and extraordinary infrared sensitivity, is ideally suited for studying objects like Threeey Atlas. Webb can detect heat signatures and identify specific chemicals and minerals on the object's surface. Astronomers have already secured valuable observation time on Webb for detailed studies of this interstellar traveler. Despite its age, the Hubble Space Telescope continues to provide invaluable data as well. Its ultraviolet capabilities complement Webb's infrared observations, offering a more complete picture across different wavelengths. Together, these space telescopes can reveal details about Threeey Atlas that would be impossible to obtain from Earth's surface. Beyond just observing, astronomers are also listening. Radio telescopes like the Very Large Array in New Mexico and the Allen Telescope Array in California are monitoring for any unusual radio emissions. While no one seriously expects to detect alien broadcasts, these observations help assess whether the object emits any radio waves as it interacts with the solar wind, the continuous stream of particles flowing from the Sun. As Threeey Atlas draws closer to the Sun, it will become more visible, its brightness increasing. If it is indeed a comet, it might develop a more pronounced tail, offering further clues about its nature. This would provide scientists with even more material to study, as the tail contains particles and gases released directly from the object itself. The discovery of Threeey Atlas is viewed by many astronomers as the dawn of a new era in our comprehension of interstellar objects. For all of recorded history until 2017, we had never confirmed a single visitor from beyond our solar system. Now, within fewer than 10 years, we have identified 3. This is not mere coincidence, but rather the result of significant technological progress. Our ability to detect these cosmic travelers has dramatically improved in recent years. Automated sky surveys, more powerful telescopes, and advanced software capable of identifying unusual motion patterns have all played vital roles in this transformation. What we observe now is likely not a sudden rise in interstellar visitors, but rather the emergence of the capability to detect what has always existed. When it begins operation, the Vera Rubin Observatory will take this detection capacity to an unprecedented level. Equipped with a massive camera, it will image the entire visible sky every few nights, effectively creating a cosmic movie that will make spotting moving objects much easier. Experts predict it may discover several interstellar objects annually, possibly even dozens. This expanding catalog of interstellar visitors will enable scientists to answer questions that were previously only speculative. Are most interstellar objects comets, asteroids, or something else entirely? Do they tend to originate from the inner or outer parts of their home star systems? How frequently are planetary systems ejecting material into interstellar space? The answers to these questions will revolutionize our understanding of planetary system formation and evolution. There is increasing interest in the idea of launching spacecraft to intercept interstellar objects. Although Threeey Atlas was discovered too late for us to mount such a mission, several space agencies and private companies are currently developing concepts for rapid response spacecraft that could be launched quickly if another interstellar object is detected early enough. Beyond pure scientific inquiry, these discoveries are shifting our perspective on our place in the universe. Each interstellar object provides a tangible connection to another star system, physical proof that the space between stars is not empty, but traversed by material ejected from far-off worlds. In this way, our solar system is not isolated but part of a larger galactic ecosystem where matter from one star system can eventually become part of another. Thanks for watching this episode. While you're still here, don't forget to click the video on your screen for more quality content.